why are you interested in robotics? If you're like me, you love assembling the robot kits, 3D printing, designing and soldering PCBs, and then writing the codes. The real fun comes when you control it with a radio controller. And that's awesome. However, if that's all you enjoy, I'd suggest keeping it as a hobby. An engineering job or graduate program for robotics might suffocate your passion in your hobby, as it did once for me. And it took some time for me to catch up and integrate the science of robotics with my hobby. So Elliot, what is it like then, right? Instead of just describing the job, here's an interview question I got for a company making a small indoor robot 2D LiDAR. If a user holds the robot and lifts it up and blocking the LiDAR, what did you do? It was an embarrassing question because once the product is in the user's side, it's out of my hand. As an engineer, what can you do? So my first thought was to add a warning sticker advising not to block the LiDAR alongside others like don't put this robot in the microwave, that kind of thing, right? Because the users like this for engineers is even more dangerous than the hackers, aren't they? But of course I didn't say that because this was an engineering position. In this video, let me share the answer that got me a job offer, and then I'll discuss what you should and shouldn't expect from a robotics engineering job to give you a realistic view of the field. And if you're new to here, my name is Elliot. I'm a robotics engineer, educator, and entrepreneur providing the services and insights on robotics engineering. So the first things first, the question was, what did you do when a user of the robot blocks the robot's LiDAR view? The correct and high-level answer is, I'd implement an error state common filter to track and minimize the error. Sounds odd, right? From my experience, the interview questions are like this and often aim to check the three abilities of a candidate: your capacity to assess the situation or mission of the robot and then identify the issues and solve the problem. So here's my thought process. If this robot uses a LiDAR for autonomous navigation, it's likely to have inertia sensors. So I asked if I still had access to accelerometer data, and then they said yes. Integrating the acceleration twice gives you the robot's position. But the accelerometers are noisy, so integrating a noise signal causes errors due to the random walk, which I talked about it in different video, here or there. So without knowing the ground truth for the position, estimating the error for position is quite challenging task. And that's where the error state common filter comes in. It tracks the error from the start. When the LiDAR isn't blocked, the error is minimal because it compares the accelerometer integration with the LiDAR-based position. Once the LiDAR is blocked, then the error grows, but when it is unblocked, error decreases. So by subtracting this error from your position estimation, the robot's position estimation accuracy improves. So regarding the robotics, what should you expect for the graduate programs or for the jobs? Let me answer some common questions from the people who are interested in robotics. First, why is sensor fusion so important? Isn't GPS enough? I've done Arduino projects with GPS and it's easy to read the GPS data. It's great that you have an experience. Robots often use GPS, of course, but it doesn't really work well in indoor environment, tunnels, underground parking lots, or underwater, and so on. Also, without RTK correction, the standard GPS has about 15 to 30 feet of error. So for indoor navigation requiring higher precision, you'll need other sensors like LiDAR or cameras. And this is known as a GPS-denied situation, and sensor fusion in such cases requires a solid mathematical background because it's about combining the information. It's much like data science. And the second question, isn't working with ROS or Arduino important? Isn't that good enough? Why are you keep talking about something other than ROS? Absolutely, being familiar with those tools are quite necessary skill set if you're looking for a job. But let me use a doctor analogy. Say, knowing how to use the surgical tools like this doesn't make someone a doctor. They need to understand the human body's science. Say, if you touch this organ, then this blood pressure may drop or increase. Then another organ may be affected, which would cause the oxygen level in your blood vessel, and this may cause the first organ again to fail, and so on and so on. I don't know, I just made up this story, and I think this is quite common for not just for medical fields, but also for any fields with expertise. If you're looking for a lawyer, Same. If you're looking for a pilot, same. So why not robotics engineering? So I think it is fair that companies expect engineers to have expertise in the scientific principles of robotics, not just proficiency with the tools like ROS and embedded systems. Actually, they want experts who understand both the science and the tools. Are there any standardized tool stacks for robotics engineering, like similar to MERN stack in web development? And I say, yes, there is, the MCP stack that I made up, math, code, and physics. It might sound like saying, well, to be healthy, you gotta exercise every day. But isn't that true though? So you might ask, okay, Elliot, sounds good, but which topics of math, code, and physics are essential in robotics? And my short answer is calculus, linear algebra, differential equations, statistics, physics, dynamics, and programming languages like Python and C++. Well, it sounds too much? Well, actually, these are the typical topics that most of the engineering colleges would cover for the first and second year students. And here's why they are necessary. For example, in a GPS-denied situation, you might use a camera. Processing real-time images to get the meaningful information like velocity and position may involve convolutional neural networks. Combining the velocity from the neural network with another source of information using common filter enhances the accuracy. And I just mentioned the convolutional neural network, which is deep learning, and then deep learning requires understanding of gradient descent, matrix operations, and statistics. Common filter involves Gaussian distribution and matrix computations. And to implement all of these, you need to use programming languages. And to be able to debug it, the robot, you need to be able to assess the situation, so-called runtime error in robotics, that happens in real life. So it's about concerning and understanding math, code, and physical phenomena. What is a day in the life of a robotics engineer like? Once you start your job or grad program, you might go to the lab or actual office, then you will likely work with a robot that is already been assembled. You will receive the data to analyze the model. Your task is to understand the data and resolve the problems, possibly by reading the research papers, watching the YouTube tutorials, or secretly asking to ChatGPT. For example, if you have a happy day or a lucky day, you don't have any meetings, no code to debug because no clients complained about the features, or no Git push request, no errors to debug, right? You don't have to read others' code. That's the happy day. And if that happens, what you would do is something like this. Here's a snapshot from one of my best days. I had the data from a UAV to determine a lift and pitching moment coefficients. The flaps deflection angle was theoretically supposed to be 0, but the result doesn't show that. So it was a clear problem requiring systematic checks. Ensure the motor's input voltage was constant during the data collection. Verify if your least square fitting strategy is appropriate. Should you use gradient descent or even simpler method like Newton-Raphson method? Confirm the wing was properly 3D printed. Now, I may have kind of depicted robotics engineering as a bit of grayscale image, which is a little boring. But hey, don't get me wrong, I started my career from my hobby, though it was a bit tough at the beginning. Once I made a single breakthrough moment, after that, it's pretty exciting career. You could go out to the field and actually fly your robot or control your robot or test your robot that you have been developing and collect the data. If it doesn't work, good luck. But isn't that cool though? I love it 100% and I recommend it. I just wanted to share a bit of more practical aspects of robotics engineering with you, so you don't have to go through the frustration or depression like me in the past due to the discrepancy of my expectation and the practical task, which is about more like data science, which is again all about the applied math. And that's it. If you think this kind of content is helpful, please hit the like button and subscribe my channel. My name is Elliot. I'll see you around. Make sure you're loading the data from the correct file. Validate your theoretical model's expectations. Read the paper again.